Despite the 2015 COP21 Paris Agreement on climate change, we are experiencing a global rise in CO2 emissions. To overcome this discouraging scenario, the European Commission is working hard towards the development of greener and renewable energy sources, as well as supporting the transition to a low-carbon economy in the European Union.
So in this scenario, the MefCO2 project was born in December 2014. We have built a pilot plant that reutilizes captured CO2 emissions and hydrogen produced from renewable energy sources to produce a versatile low-carbon methanol that can be used either as a chemical building block or as a fuel. The MefCO2 project contributes to the ambitious goals established by the European Commission in two ways. First, it provides a more attractive business case for CCU and CCS. And second, it enables the integration of higher shares of renewables by stabilizing the grid and also by using renewables to produce methanol.
We are now in the final stages of the project and we are running tests in our pilot plant located in Germany. It has a mini fee. During the project we had to change the site for the demonstration of the project, and thanks to the help of RWE, we finally managed to erect the plant at the Coal Innovation Center in Niederhausen. Thanks to the great job by the consortium partners and RWE's commitment, we made that for lost time and we managed to adapt to the new scenario.
Another challenge is related to the catalyst and the process engineering. Our colleagues from the National Institute of Chemistry in Slovenia and the Cardiff Catalysis Institute has worked very hard in the development and characterization of new catalysts, a work that has derived in a patent request from CCI. In order to meet the project goals, it was essential for us to make sure that our industrial partner, Carbon Recycling International, runs a series of tests at their laboratory in Iceland in order to prove the potential of this new catalyst and also to start working in the future commercialization.
The third greatest challenge is to obtain relevant results from the test campaigns and to prove the feasibility of this technology for future and real applications. Both the CO2 capture and compression units owned by RWE were already erected on site at the power plant of Niederhausen. The remaining components were delivered on October 2018. The height of the CO2 captured unit is around 40 meters, with a capture capacity of 7.2 tons of CO2 per day, which is equivalent to a separation efficiency of 90% for the flue gas amount processed. The captured CO2 is dispatched to RWE's compression unit. The CO2 conditioning unit, owned by Mitsubishi Hitachi Power Systems Europe, is placed next to it. This unit decompresses the CO2 and provides it to the methanol reactor. MSPSC is also the partner in charge of the integration of the different technologies within the pilot plant. On the 23rd of October 2018, the methanol reactor unit owned by CRI arrived at the site. The methanol unit is responsible for the conversion of CO2 and hydrogen gas streams into methanol at a production rate of 1 ton of methanol per day.
So once the methanol unit was positioned, a different crane arrived to lift the electrolyzer, which has been designed and manufactured by Hydrogenics. The electrolyzer is a two-container unit. The first one hosts a 600 kilowatt cell with a proton exchange membrane able to produce 120 cubic meters hydrogen per hour at a purity of 99.99%. The second container comprises all the needed ancillary equipment, such as the control system, the demineralized water system, and the water cooling loop. The cooling unit was the last piece of the electrolyzer to arrive at the site and was positioned on top of the container. Lastly, a 26 cubic meters storage tank where the crude methanol produced will be stored is located in front of the methanol unit. The tank is sitting on top of a sump to prevent leakage and will be surrounded by fire protective walls and ceiling. When the tank is close to full, the crude methanol will be loaded to a truck and transported to the end user.
In parallel to the site construction, the University of Genoa, along with the University of Duisburg-Essen and NIC, had been working hard in economic and process simulation of the pilot plant. Relevant data from the literature and also from the plant operation has been used to carry out a sound thermoeconomic analysis. The main challenges here are to demonstrate the technical and economic feasibility of these type of plants, to align the simulations with the plant operation, and to be able to generate papers reflecting the potential of integration of the technologies being used in the MefCO2 project. In addition, the life cycle analysis is a crucial tool to guarantee that we are producing a low-carbon methanol.
Last but not least, the coordination of 9 partners from 7 different countries has also represented a challenge in terms of cultural differences, communication, and decision-making. In this sense, IDEALS as project coordinator has been involved in the different activities of the project, aiming to facilitate iteration among partners and also to supervise the different risks to guarantee the successful implementation of the action as agreed with the European Commission.